This experiment is about electrical circuits. We need batteries, LED, light bulb sockets, light bulbs, wires, and battery holders. In the first experiment, we will light up this bulb. We need these things. This is a battery. This protruding end is the positive terminal. This flat end is the negative terminal. This is a light bulb. This protruding end is the electrical foot contact. This grooved band is the screw thread contact. In addition to the battery and bulb, we need a wire. Connect the battery's negative terminal to one end of the wire. Connect the bulb's electrical foot contact to the battery's positive terminal. Connect the other end of the wire to the bulb's screw thread contact. Notice that the bulb lit up. Sometimes it is bright, sometimes it is dim, sometimes it flashes. To make the brightness consistent, put the light bulb in a socket. Screw the bulb into the socket. Notice that the bulb is now fixed in place. Put the battery in the holder. The spring should come into contact with the battery's negative terminal. The battery holder is attached to two wires. Touch the ends of these wires to the socket. The bulb is consistently bright. Hook the wires into the holes of the socket. We just made a closed circuit. What will happen if we add more wires? Let's test and see. Unhook the wires. Wind the red wire to another red wire. The colors should be similar to make it easy to identify the terminals. Wind the black wire to a black or blue wire. Hook the blue wire into a hole of the socket. Hook the red wire into the other hole of the socket. Notice that the bulb is bright. After adding two wires, the bulb still lit up. What will happen if we add another wire? Let's test and see. Wind one end of the wire here. Touch the other end of the wire here. Notice that the bulb went out. Wind the wire. Earlier, the bulb was bright. After connecting this wire, the bulb went out. It is not broken. Rather, current did not flow through the bulb. As a resistor, the bulb limits the flow of current. So instead of flowing through the bulb, current flows from the battery's positive terminal through the wire and to the battery's negative terminal. This is called a short circuit. A short circuit heats the wires and battery. It is dangerous. We must avoid it. The next experiment is about batteries in series and parallel. Let's connect two batteries in series. Two batteries are in series when the positive terminal of one battery is connected to the negative terminal of the other battery. However, the batteries might move if you hold them this way. They might even move apart. These would lead to poor connection. To hold the battery in place, put it in a holder. Wind the wires to form a series connection. That is, connect the positive terminal of one battery to the negative terminal of the other battery. Note that the red wire is connected to the positive terminal and the black wire is connected to the negative terminal. So the terminals are positive, negative, positive, and negative. Wind the black wire to a red wire. The wires are now connected. To see the bulb's light more clearly, turn off the room's light. Hook a wire into a hole of the socket. Hook the other wire into the other hole of the socket. Notice that the bulb lit up brightly. Remember this brightness. We will need it when we compare results later. If we remove a battery from the holder, what will happen to the bulb? Let's test and see. Notice that the bulb went out. Put the battery back. Remove the other battery. Notice that the bulb went out. If a battery is removed, the bulb will not light up because current cannot flow. This is called an open circuit. This time, let's connect two batteries in parallel. To do this, connect the positive terminals to each other and the negative terminals to each other. Remember that the red wire is a positive terminal and the black wire is the negative terminal. Put the batteries in the holders. Wind the red wires. Wind the black wires. Hook the red wires into a hole of the socket. Hook the black wires into the other hole of the socket. If the wires come off, wind them again. Then hook them. Notice that the bulb lit up. Turn off the room's light to see the bulb's light more clearly. Observe how the bulb's brightness changes depending on the type of circuit. The bulb is less bright when the batteries are connected in parallel. It is similar to when the bulb is connected to just one battery. If we remove a battery from the holder, what will happen to the bulb? Let's test and see. Notice that the bulb still lights up. Put the battery back. Remove the other battery. Notice that the bulb still lights up. Remove both batteries. Notice that the bulb went out. The next experiment is about bulbs in series and parallel. We need wires, two sets of light bulb in socket, battery holder, and battery. Let's connect two bulbs in series. To do that, hook a wire into a hole of the socket. Hook the other end of the wire into a hole of the other socket. Connect the battery holder to the bulbs. To do that, Hook the red wire into the free hole of the socket. Hook the black wire into the free hole of the other socket. Make sure that you can trace a single line from the holes of one socket through the wire into the holes of the other socket. Put the battery in the holder. Turn off the room's light to see the bulb's light more clearly. Notice that both bulbs lit up, but they are not bright. What will happen if we disconnect a bulb? Let's test and see. Unhook the wire connected to a bulb. Notice that both bulbs went out. Hook the wire again. Notice that both bulbs lit up again. Unhook the wire connected to the other bulb. Notice that both bulbs went out. This means that all bulbs connected in series will go out when any one of them is disconnected from the circuit. This time, let's connect two bulbs in parallel. Arrange the bulbs so that they are parallel to each other. Look at the wires. They come in two colors, blue and red. Connect the red wires to the battery's positive terminal and the blue wires to the battery's negative terminal. This will make it easy to identify the terminals. Hook a red wire into a hole of a socket. Hook a blue wire into the other hole of the socket. Get the other bulb. Hook the other red wire into a hole of the socket. Hook the other blue wire into the other hole of the socket. Now, the holes of the sockets are all connected to a wire. Also, wires of the same color are parallel to each other. Wind all the red wires together. Wind the black and blue wires together. Put the battery in the holder. Turn off the room's light to see the bulb's light more clearly. Notice that bulbs in parallel are brighter than bulbs in series. What will happen if we disconnect a bulb? Let's test and see. Unhook the wire connected to a bulb. Notice that the disconnected bulb went out, but the other bulb still lights up. Hook the wire again. Notice that both bulbs lit up again. Unhook the wire connected to the other bulb. Notice that the disconnected bulb went out, but the other bulb still lights up. This means that if bulbs are connected in parallel, only the disconnected bulb will go out. The connected bulb will still light up with the same brightness. Based on the experiments, the bulb is brightest when batteries are connected in series. This is followed by bulbs or batteries connected in parallel. The bulb is least bright when bulbs are connected in series. An LED has two pins. The long pin is connected to the battery's positive terminal. The short pin is connected to the battery's negative terminal. Turn off the room's light to see the LED's light more clearly. Connect the red wire to the long pin. Connect the black wire to the short pin. Notice that the LED did not light up. Add another battery. We now have two batteries in series. Connect the red wire to the long pin. Connect the black wire to the short pin. Notice that the LED lit up.